Welcome to the deep dive. Today, we're looking at something, well, pretty paradoxical. Solar power, but also using rain.
Right. It sounds completely counterintuitive.
Doesn't it? But we're exploring how these hybrid solar systems are starting to change things up in Maine, tapping into both sun and rain for energy.
Yeah, and it's especially interesting given Maine's climate. So in this deep dive, we're really looking at, how feasible this is, what's actually being done now, and the environmental side of things. And what's really wild is, people think of Maine as maybe not ideal for solar, but it gets about 33% more sunlight annually than Germany.
Wow, Germany, a huge solar player.
Exactly. So Maine's actually got massive potential, even with the, let's say, reputation for tricky weather.
That's a huge starting point. So, okay, how do we square that potential with the rain and snow reality? Our sources today cover, well, quite a range.
They really do.
We're looking at the tech stuff like Triboelectric nanogenerator TNs, right? But also actual projects on the ground and the policies helping it happen.
Yep, all of that.
So let's start with where Maine is now with solar. Because despite what you might think, adoption is really taking off.
It is, yeah, real surge.
And we're talking typical home systems, maybe 8 to 12 kilowatts, costing somewhere between $22,000 and $54,000 roughly before the federal credits kick in.
Right. And a key point, maybe a myth buster. Panels actually perform better in the cold.
Oh, interesting.
Yeah. And snow, well, it covers them sometimes, but long term, it's not a huge issue. They tend to self-clean as it slides off.
So snow isn't the big enemy.
Not really. The bigger issue for output is actually partial shading, from trees. That can slash production by up to half.
50%.
Okay.
So that brings us back to the clouds and rain. What role does rain play besides just, well, being wet?
Right. So rain actually has this hitting benefit. It's a great natural cleaner for the panels.
Like a car wash.
Pretty much. It washes off dust, pollen, that sort of thing. And that alone can boost efficiency by, say, 3 to 5% over a year.
Just from the cleaning.
Just from the cleaning. Plus, even on really overcast days, panels don't just quit. They capture diffuse light, still generating maybe 10 to 25% of their peak power.
Okay.
Especially the newer bifacial panels, which capture light from both sides. But yes, long periods of heavy rain will cause a dip in production, and that's where these hybrid systems really come into play.
Right. So if the rain eventually hurts production, how on earth do we get power from it? It still sounds a bit sci-fi.
Doesn't it? But the tech is real. One way is using those triboelectric nanogenerators, the Tenrecs.
Okay, Tenrecs.
These are really thin, layered materials. You put them right on top of the solar panel, and they basically harvest the kinetic energy when raindrops hit them.
Kinetic energy, so the motion of the drop.
Exactly, the impact. They use these textured films. Some research even used patterns from old DVDs, believe it or not.
Huh, really? DVDs?
Yeah. Now, the output from one drop is tiny. Really tiny, maybe enough to power a small sensor.
Okay, so not powering the whole house during a storm.
Not yet, anyway. But the research is focused on scaling it up, potentially providing some useful backup power during storms.
Okay, so Tenyas go on top. You mentioned another approach.
Right. There's also piezoelectric add-ons. These go underneath the solar panel.
Underneath, how do they work?
They sense the mechanical stress, the impact of the raindrops hitting the panel above, and convert that stress into electricity.
Like squeezing a crystal.
Sort of, yeah. Piezoelectricity. Early tests show arranging these sensors in parallel captures more energy than putting them in series. But the big question in Maine is durability. The freeze-thaw cycles. That's still being tested hard.
Makes sense. So, okay, tangs on top, piezo underneath.
Mm-hmm.
Are people actually doing this in Maine? Are there examples?
Oh, yes. And this is where it gets really practical. There was a pilot project in Freeport in 2024, Maine Solar Solutions.
Okay.
They set up a 15-kilowatt hybrid system, bifacial panels and these piezoelectric underlayers. And during one big downpour, it generated 1.2 kilowatt hours just from the rain.
1.2 kilowatt hours from rain. What does that translate to?
Well, for that house, it offset about 18% of their nighttime electricity use. And here's the kicker. After the storm, the panels were cleaner and their efficiency went up by 4.3%.
Wow. So you get power during the rain and better performance after.
Exactly, that dual benefit.
Yeah.
And the University of Maine's research is showing similar promise with tongues, finding like a 14% boost in winter generation on arrays using them. It really shows the model works.
That's impressive. So practically speaking, for installers, What are they focusing on to make sure these systems handle Maine's weather? 40 inches of rain annually isn't trivial.
No, it's definitely not. So they're using materials that resist corrosion, obviously, and they're setting panels at steeper angles, usually 30 degrees or more, to help water just run right off.
Right, shedding the water.
And ground-mounted systems are pretty popular too. You can often position them better for shedding rain and snow, and they're easier to maintain.
Okay, so let's connect this to the money and the environment. What does adding rain capture and battery storage do for the homeowner's bottom line or for the grid?
Good question. Financially, if you pair solar with battery storage, like a Tesla Powerwall, for instance, the payback period in Maine can be around 12 years. That's pretty attractive, especially with utility rates around 21 cents per kilowatt hour.
And that storage helps with grid stability too, right?
And
Especially during storms.
absolutely crucial. Having that local backup power helps the whole grid during Maine's, sometimes pretty extreme weather. Environmentally, there are always questions about materials, maybe heavy metals.
Hmm.
But sticking to strict standards, like IEC 61930, plus regular checks and good recycling programs really minimizes those risks. And then there's this really cool idea, agrivoltaics.
Agrivoltaics, like agriculture and photovoltaics.
Exactly. You mount the panels high enough off the ground so you can use the land underneath, maybe for sheep grazing or planting pollinator habitats, wildflowers.
So that's smart.
It really is. You get energy production and ecological benefits on the same land, a great way to balance different needs.
This whole conversation really shifts the idea of what solar power is, doesn't it?
Mm,
Not just for perfect sunny days.
it really does.
And when you look ahead, I mean, things like perovskite solar cells hitting maybe 33% efficiency even in low diffuse light, and using AI for predictive maintenance, which is apparently already boosting yields by 7% in places like Portland, Maine could genuinely become a leader in, well, all-weather renewable energy.
It really could. And that leads to a bigger question, really, for you listening. As this tech gets better, making our energy systems more resilient and tackling climate issues, how do we make sure everyone can actually access these innovations, especially with energy demand always rising? What part of this, rain-resilient future really catches your interest?